PFAS exposure and sleep disruption. New evidence links forever chemicals to reduce sleep and long-term health risks. Introduction. Per and polyfluoroalkyl substances, PFAS, often referred to as forever chemicals, are synthetic compounds widely used in consumer and industrial products for their resistance to water, grease, and stains. Despite their practical uses, PFAS persist in the environment and accumulate in the human body over time. New research now highlights a concerning link between PFAS exposure and disrupted sleep among young adults, a finding that adds to the growing body of evidence connecting these chemicals to long-term health risks. Perfluoroalkyl substances and their ubiquity in modern life. PFAS are found in thousands of consumer products, including non-stick cookware, waterproof clothing, take-out food containers, carpets, and even personal care products like shampoos and makeup. Due to their stable chemical structure, they do not easily break down in the environment or the body. The Centers for Disease Control and Prevention, CDC, reports that the majority of Americans have measurable PFAS levels in their blood regardless of age, location, or lifestyle, despite regulatory efforts in some regions to limit or ban specific types of PFAS. These chemicals continue to be produced and released globally, contributing to widespread contamination of water, air, soil, and food. New research links PFAS to sleep disturbances. A recent study conducted by researchers at the University of Southern California, USC, explored how PFAS may be interfering with sleep in young adults. The team analyzed blood samples and sleep patterns of more than 140 individuals aged 19 to 24. The study focused on 4 well-known PFAS compounds: PFDA, perfluorodecanoic acid, PFHXS, perfluorohexane sulfonic acid, PFOA, perfluorooctanoic acid, and PFOS, perfluorooctane sulfonate. The findings revealed that individuals with higher concentrations of these PFAS in their blood slept significantly less, in some cases up to 1 hour and 20 minutes less per night, than those with lower exposure. Among the compounds studied, PFAS showed the strongest association with difficulties falling asleep, staying asleep, and feeling rested the next day. Sleep quality is a cornerstone of physical and mental health. Chronic poor sleep is a well-established risk factor for a range of conditions, including obesity, type 2 diabetes, memory impairments, cardiovascular disease, and neurodegenerative disorders such as Alzheimer's. This makes the potential impact of PFAS on sleep a serious public health concern, especially for young adults in a critical stage of cognitive and physical development. How PFAS may disrupt sleep, a molecular perspective. To better understand the biological mechanisms at play, the USC researchers also explored how PFAS might alter gene expression, particularly genes involved in sleep regulation. They identified 7 genes that appeared to be affected by PFAS exposure. Among these genes were those responsible for producing cortisol, a hormone that regulates the body's circadian rhythm, and cathepsin B, a gene linked to memory processing and implicated in Alzheimer's disease. Elevated cortisol levels at night can delay sleep onset, cause frequent awakenings, and lead to daytime fatigue, a pattern observed in participants with high PFAS levels. Disruption of cathepsin B could further compromise brain health, memory consolidation, and long-term neurological function. These genetic findings suggest that PFAS exposure during key developmental windows, including in utero and early childhood, may set the stage for long-term sleep problems and related health consequences. Perfluoroalkyl substances, exposure in vulnerable populations. While this study focused on young adults, the implications extend to other vulnerable populations, including pregnant individuals, infants, and children. Prenatal exposure to PFAS has been linked to a variety of developmental concerns, including low birth weight, hormonal disruption, immune dysfunction, and now, potentially, disrupted sleep architecture. Because sleep plays a critical role in childhood brain development, even subtle disturbances could have meaningful impacts on learning, behavior, and emotional regulation. Minimizing PFAS exposure. Practical steps for prevention. Although completely avoiding PFAS is difficult due to their widespread use, several measures can help reduce exposure. Filter drinking water using a certified reverse osmosis or activated carbon system known to remove PFAS. Avoid non-stick cookware and opt for stainless steel, ceramic, or cast iron alternatives. Be cautious with personal care products, especially those labeled as long-lasting and waterproof or oil-resistant. Reduce consumption of fast food and packaged products, which often come in PFAS-lined containers. Check product labels and seek brands that explicitly state they are free of PFAS or PFCs. Conclusion. The University of Southern California's study provides compelling evidence that PFAS exposure may negatively impact sleep quality in young adults, potentially setting the stage for long-term health issues. By revealing both behavioral and genetic links, the study emphasizes the urgency of addressing environmental PFAS contamination and educating the public about ways to reduce exposure. As research continues to unveil the broad health consequences of these forever chemicals, it becomes clear that effective regulation, widespread testing, and cleaner consumer choices are crucial steps toward protecting future generations from preventable harm, starting with something as fundamental as a good night's sleep.